Alright, video number 3, 6th period, multiples of 3 of the review. And you can click on the other links to find the other videos and be ready to study, enjoy, whatever. Number 3, graph of the function g is shown on the right, composed of 2 line segments and 2 semicircles. Oh, there's the other line segment. For what values of x, negative 5 to 5, is g not differentiable? Okay, not differentiable would be places where it is not continuous, where there's a cusp, and where there's a vertical tangent line. Because a vertical tangent line, it could have a tangent line there, but that slope is undefined, which would mean the derivative is undefined. So, cusps, sharp turns, that'd be right there at negative 4, and right there at negative 3. It looks like it's continuous everywhere, so I don't have to worry about that. Vertical tangent lines, looks like that would be right there at 1. So negative 4, negative 3, and 1. The only other options are 1 and 3, so maybe I should, negative 1 and 3. Oh, negative 1, there's a horizontal tangent line, and 3, there's a horizontal tangent line. But that's okay, that slope is 0, not undefined. So we're okay with those spots. So cusp and vertical tangent lines don't have derivatives. Number 6. Which of the following is an equation of the tangent line to the graph at the point where f prime equals 2? Oh, well, that's kind of interesting. So I want where the slope is 2, and then kind of back up and figure out what the tangent line looks like. Equation of a tangent line. So I need point and slope. I guess I know slope already. Slope's 2. But I need to work backwards and figure out what point that happens at. So f prime is 3x squared plus 2. We'll set that equal to 2 because we said the derivative was equal to 2, which is pretty convenient. Subtract 2 from both sides. X squared equals 0, so x equals 0. So the slope is 2 when x is 0, and when x is 0, the y value is negative 1. So now I've got a point in the slope. I can write a line. Y plus 1 equals 2 times x minus 0. So y equals 2x minus 1. That was worded kind of funny, but we got there. Number 9. For what values of k is h of x continuous? Well, the spot we might be worried about is at 3, because that's where we jump from one branch to the other. So we need at 3, we need these two things to be equal to each other at 3. X squared plus x needs to equal 4x plus 4 at x equals 3. Anywhere else we don't really care, but at x equals 3, they need to be equal. So let's plug in 3. So 9k plus 3 equals 12 plus 4. Plugged in 3 for x. So 9k equals 16 minus 3 is 13. So 13/9 would make that continuous. K of 13/9 would make them match up. Number 12. Limit as x approaches 4. If I plug in 4, I can pretty quickly see I get 0 over 0. So I could do L'Hopital or I could do factoring. I don't know which one's easier. Like if you know how to factor a cube, then it's pretty easy. But L'Hopital is pretty easy as well, because the derivative of the top would just be 1. and the derivative of the bottom would be 3x squared. So that's pretty easy. 3 times 4 squared. 16 times 3 is 48. So 1 over 48. I did it with L'Hopital's. Easily could have been done with factoring. Same, opposite, always positive. And you'd get 1 over 48. So either way. Just be careful with L'Hopital's. Remember what triggers L'Hopital's is 0 over 0 or infinity over infinity. Don't be using it if it's not that case. Number 15. Derivative of cotangent of x squared. Okay, derivative of cotangent. Well, tangent is secant squared. So cotangent is negative cosecant squared of x squared. But then chain rule times 2x. So negative 2x cosecant squared of x squared. Number 18. If the function is continuous at 3, which of the following must be true? Okay, so at 3 the function's continuous, so something normal, but maybe something not quite so normal, like it could have a cusp there. F of 3 is less than the limit as x approaches 3. No, continuity means the limit from either side equals the limit of the function, so no, it can't be less than, it's got to be equal to. The limit from the left does not equal the limit from the right. No, the point of continuity is that the limit from both sides comes to the same spot. The derivative of f at x equals 3 exists? Maybe. Like yes for this one, but no if it's a cusp. So I think that's out because it's not a must true. That's a maybe true. And then that last statement. Oh well, that is like literally the definition of continuity. So if a function is continuous at 3, then it fits the definition. The function equals the left limit equals the right limit. So that was a reminder of the definition of continuity. The graph of function g, 3 line segments, is on the left. F of x is 3x minus 2, and we want the derivative at 2 of g of f of x. Okay, so let's find the derivative first, then we'll worry about plugging in 2. So outside in, one layer at a time, g prime of f of x. That's the outer layer. And then the inner layer, derivative of f of x would be f prime of x. Okay, so I guess now let's plug in 2 and see what happens. So g prime at f of 2 times f prime at 2. F of 2 we can get from our function over here. F of 2 would be 4. F prime of 2, so I need a derivative of f. That's 3. In fact, always 3. So f prime at 2 is the same as f prime anywhere else. 3. And then g prime at 4, right there, that's the slope of g at 4, so that's negative 1. So negative 1 times 3 would be negative 3. A lot of pieces to that one. Chain rule with a function and with a graph, with an equation and a graph. Instantaneous rate of change, also known as derivative. So take a derivative, plug in 3. This should be an easy one here. 2x minus 7 to the first don't forget the chain rule with an extra 2 out there from the derivative of the inside. So that would be 4 times 2 times 3 minus 7, negative 4. (27) F prime at 2. Oh, this is one of those weird ones where we're we're changing functions at 2. So we need to check a couple of things, what's going on here. We need to check the function at 2 to see if the orange one and the green one meet at the same spot, right? Because if there's a jump there, then there's no derivative and we're done. And then if they do meet there, we'll have to check to see if they meet, if they meet smoothly. So f of 2 will tell us, do they meet? F prime of 2 will tell us, I guess another way to say it would be, is there a cusp? If their slopes are different, then there's a sharp point. Okay, so f of 2, that would be 3 times 2 squared plus 5. Let's see, so 3 times 4 is 12, plus 5 is 17. 12 times 2 minus 6 is 18. So those graphs don't even meet. There's a jump there. So it doesn't matter what their slopes are. They are not continuous. And if the function is not continuous, it can't have a derivative there. This one's kind of tricky though, because if you skip that step and you're like, oh, let's just check the derivative from either side. So I have 6x, and if I plug in 2, that means I get 12. And for the other one, the derivative is just 12. So they do have the same derivative, but there is a jump there. So you've got to check continuity. You can't just check their derivatives. So what that would mean is they have the same slope, but there's a jump there. So you can't take a derivative there. Number 30. Slope of the line tangent to the graph. So that's dy dx, or derivative. This thing, that looks terrible, so I think I want to split that up. That's just algebra. I haven't done any calculus yet. I'm going to do one more algebra step. Move the exponent to the front. And now I'm ready to do some calculus, but now my calculus will be a lot easier. So 2 times 1 over x plus 1/2. X cubed minus 1 in the bottom. 3x squared in the top. Done, but that doesn't look like my answer choices because I guess I need a common denominator. Algebra. So my first term needs a 2. Top and bottom, and an x cubed minus 1. And my second term just needs an x. So now my denominators match. Let's distribute the 4. So 4x cubed minus 4 plus 3x cubed. So that's 7x squared minus 4 over letter B. Instantaneous rate of change, so derivative. Let's see, 3's along for the ride. This is an exponent, so the exponent stuff stays the same. 2 to the negative x squared. But the derivative of negative x squared is negative 2x. And because the base isn't e, I need a natural log of 2. So what is that? Negative 6x out front. Answer A. Not hard, but lots of rules thrown in there. 36. Limits. I'll plug in first and see what happens. But that's 0 over 0. I can't deal with that. That one's not eligible to be factored or any of the other algebra tricks. So what is supposed to be triggering in our brain here when we see 0 over 0? Well, yeah. L'Hopital. L'Hopital is a rule. So limit as x goes to 0. Derivative of sine is cosine. Derivative of x is just 1. We plug in again. Cosine of 0 over 1 is just 1. Again, L'Hopital's is great, but only use it if you have 0 over 0 or infinity over infinity. Makes life easy, but only use it when you're supposed to. 39. Let's plug in infinity and see what happens. But 3 plus infinity over infinity squared plus 7. So I got to be careful about this is the which infinity is more infinity than the other infinity situation. So the 3 and the 7, that doesn't do much for me. But who's bigger, natural log or x squared? Which is the bigger, stronger infinity? X squared. Right? Natural log is just barely increasing. X squared, the parabola. So, yeah, it gets big, but it gets really big on the bottom. So what's a little big divided by a really big? That would be 0, or approaching 0. Lastly, 42. Looks like it's kind of the same thing because I've got infinity minus infinity over infinity plus infinity. It's like all these infinities. Who's bigger? Let's see. So think back to the x to the x was the biggest infinity. X factorial was the next one down because it still had x factors, and some of them were big, although they were getting smaller. And then it was exponential stuff, like 3 to the x, and then it was x squared, and then you don't have to do anything after that. So the biggest one here is that negative x factorial right there. Everything else is eventually going to pale in comparison to that one. Everything else is smaller than that. So we're headed toward negative infinity. Alright, all the answers are now posted. Hit like and subscribe. Make sure you catch all my videos.